So as Mrs. Mack's video very clearly showed us, if we're looking for the volume of a pyramid has exactly 1/3 the volume of a prism. That's a prism with the same base and the same height. I don't know if you paid attention, but she was very clear to say that the prism was a square just like her pyramid with the same base, and they also had the same height. So this is very important to realize. So the video demonstrated very clearly that it took 3 pyramids to fill up the prism. So if I asked you for the volume of the prism, you would say you needed 3 pyramids. But if I'm asking you to find the volume of a pyramid, let's change colors here, the volume of a pyramid given the prism, then instead of saying it took 3, it's the opposite of multiplying times 3. It would be dividing by 3. So if you have the prism, to find the volume of the pyramid, you would need to undo adding the 3 times that she filled it up, and that would be the inverse operation, which would be division. So the volume of a pyramid, this is the formula, and Mrs. Mack showed you how they derived that formula. It takes 3 pyramids to fill up a prism, so to find the volume of a pyramid, you would take 1/3 the volume of a prism. So again, we could try to draw this and make this 3-dimensional. Let's see if I can do that. So if you were to think of this as a prism, inside the prism there is a pyramid, and you see all the empty space that's left in this drawing. Okay, so that's 2/3 of the prism that's empty, because 1/3 of the prism is the pyramid. So bottom line, this is our formula. For the volume of a pyramid, it's 1/3 the area of your base times your height. So it's going to be 1/3 of length times width. Let's put our feet in there. 1/3 of 7 feet by 7 feet, and it was 6 feet high, the height of the whole pyramid. This is the height. 6 feet here is the height of the whole pyramid. There's a little line that you can't see very well, and then an arrow pointing to it. So this is your height. Okay, so to find that, I'll punch it all in my calculator and do 49 times 6, and then divided by 3 gives us 98, and it's volume, so it's feet cubed. Again, you have feet times feet times feet, so we end up with feet cubed, and that's the formula. Alright, I don't have a demonstration video for this one, but guess what? The volume of a cone, it's exactly 1/3 the volume of a cylinder with the same base and the same height. So it's not really shocking. Since a cone has a circular base, it's basically the same thing as a pyramid, except instead of having a square or a triangular base, it has a circle base. So the same thing happens. It's 1/3 the area of the base times the height. Just remember, when it's a circular base, we don't have to just say capital B. We know our base. If it says it's a cone, then your base is pi r squared. So really, it's 1/3 the area of the base times the height, the volume of a cone. But in every cone, your base is pi r squared times height. And for this cone, it's kind of hard to see the lines here, but here's our radius, so there's our r, and here's a little dotted line with a right angle, which means this is our height. So it's 1/3 pi, and you can use your calculator for this, 4.3 meters squared times 11 meters, which is our height. So again, we're going to have meters squared times meters, so our final answer is going to be meters cubed. And when you punch this in, you can take 1/3 of pi and then say 4.3, use your x squared button, and then times 11. Don't forget to then hit equals. So the more you practice punching all of this in your calculator, the more proficient you're going to become, so that come test time you will be able to. Now, since we're using pi, it's usually going to be a decimal, because we know pi is an estimate. and this one actually rounds up to 0.0, and it's still meters cubed. So punch your calculator and check and see if you too can get 213 approximately, I should have squiggly equal sign here, approximately 213 meters cubed. Now this is for you to try, and remember, effort leads to ability. So if you try and you fail, then the next time you try, you're going to become closer and closer to being able to do it. So effort will lead to ability. Try the.
In this video, we'll demonstrate the ratio of volume of a cylinder and a volume of a sphere. We have a cylinder and a sphere with the same height and diameter. Fill the cylinder with water. And push the ball into the cylinder. The volume of the water left in the cylinder is a third of the original volume. That means the volume of the sphere is 2/3 of the volume of the cylinder.
So according to what the lady in the demonstration just showed, a sphere equals 2/3 the volume of a cylinder. So here I have a cylinder and a sphere, and they have to have the same area of the base. So here's my radius. That means they have the same radius. And they also have to have the same height. She mentioned that. So let's see if I can draw the height. Now, the height of our sphere is, of course, going to be 2 radii, because this would be a radius, and this would be a radius. So this height, our height here, is 2 of our radii. Well, if they have the same height, then that means the height of our sphere, of our cylinder that we're comparing it to, its height is also going to be 2r. Because the comparison were of a cylinder and a sphere with the same base, or the same diameter, maybe that's what she said, the same diameter, because a sphere doesn't have a base. So the same diameter and the same height. Well, a sphere's diameter is its height. So a diameter is 2 radii. So the height of the cylinder has to be the same 2 radii. So to find our volume of our sphere, this is what we're deriving here, it's going to be 2/3, and the volume of a cylinder is area of the base, pi r squared, times height. And our height is 2r. So as we multiply this out, we're going to get 4/3 pi r cubed. So the volume of a sphere, as we multiplied our numerators, 2 times pi times r squared times 2 times r, the 2 2's make 4, pi, and then the r squared times r makes r cubed. And then in the denominator, we're all over 1 here, so 3 times 1 is 3. So this is, bottom line, what you need to remember. Whenever you're looking for the volume of a sphere, it's going to be 4/3 pi r cubed. But now you've had a little demonstration, and I have shown you where that formula comes from. So if you turn into your notes, here it is. The volume of a sphere, to find the volume of a sphere, you're going to take 4/3 of pi r cubed. and R stands for our radius. So in my picture it's very hard to see, but that is a 5 inches for our radius. So it's going to be the volume of this sphere, 4/3 pi 5 inches cubed. And we'll punch the whole thing in our calculator. You could start with 5 cubed since we haven't been cubing much. There is a cubed button. You may need to find that on your calculator, or you can always say 5 times 5 times 5 times pi times 4/3. Practice punching this in your calculator and see if you get the same answer I get, 523.6. Again, we have to estimate because of pi, so I should have used squiggly equal sign, approximately 523.6. And again, our inches, we're doing volume, inches cubed. Thank you for sticking with me to the end of this video. Here are 3 for you to try. Hopefully in your notes you can see. I will highlight in case you can't. This is 3 centimeters. This radius is 14 feet. And this radius is 8, or excuse me, this one it gave us the diameter is 8 meters. Try these on your own and keep up the good work.